All right. Kia ora, everyone. Um, so this is our first lockdown lesson that you guys are watching. So I just want to explain a few things just so you know kind of what to expect with our lockdown lessons. The one from last week was a recorded lesson that I did during class, and you're going to notice that now going forward, my lessons are going to be a little bit different from the ones I do in class. Um, Mainly what we're going to do is I'm going to still kind of break up the lessons chunk by chunk. Um, and there'll be still the Google site with the recommended task for it. You guys are really lucky that this week there's only one video for you guys to watch and basically a lot of your own kind of self-directed learning because basically what I want you to work on for week 5, sorry about that, of this lockdown is to process how to identify unknown organic compounds. So basically, this is the final section of our organic chemistry topic. We'll work on this for the remainder of this week. So basically, you have this one theory lesson, and then you guys have lots of time to kind of practice, and then there's a CPR quiz as well that I want you to complete this week. And that's basically it. I know you guys are probably concerned about what's happening with the organic chemistry practice test. The current decision is that we will just wait till we're back at school so that way you guys can sit it under test conditions, allowing you to be able to use it as a derived grade if we are in lockdown during the exams. We'll also check on timing because we do have the mocks coming up, and if we'll do an organic chemistry test then anyway. So what that means is this is our final week on organic chemistry, and next week we will be starting redox, and it'll be the same sort of setup with kind of lockdown lesson videos, recommended tasks, that sort of thing. But hopefully we'll be back in week 6. We shall see. Anyway, let's get on to today's lesson, which is about identifying unknown organic compounds. This is going to be really similar to the stuff that we did for ion identification. It's just in the context of organic chemistry. On our checklist today, we are looking at number 4, which is identified unlabeled samples using the reactions above, using common reagents and indicators. And in fact, you guys have already been looking at some of these reactions. They probably were already mentioned when you were learning your function groups and your various types of reactions. So now we're just looking at it under a different lens. So you guys should hopefully have seen this image before. I know I'm using it in my class. It's a really good summary sheet from No Brain Too Small, and it is linked on my Google site if you want it. But basically, it's just reviewing all the different tests you will do to find the different types of components. One of the first things you should do, let me just get my little laser pointer. Testing-wise, is just to see if the solution is miscible in water. That can really help you determine what functional group you potentially have, and it helps you just kind of narrow it down, just like you were kind of thinking with the flow chart of the ion identification. The other things are, it's basically just memorization. What do you use for what substance? So bromine water, we know, is a really good identification test for our alkenes. It's going to be really rapid decolorization from that brown to colorless because those double and triple bonds are very reactive. I could have this work with an alkane, however, it will be a slow reaction and we do need a catalyst for that to occur. The other thing I can do if I want to test for an alkene is I could use permanganate that's been acidified. It'll go from purple to colorless. It'll rapidly decolor. If it wasn't acidified, it would go from purple to brown. So do keep that in mind in case you just make sure you either remember the acidified, or if you forget the acidified, then you know it's going purple to brown. Be really careful. The other things then are basically acids and bases that we are thinking about. So one way you can think about it is just the smell. We know that amines are very stinky, whereas carboxylic acids are very sharp. But usually on the marking schedule, they're going to want a proper test. So you'll be thinking about litmus. So basically, what color is the litmus universal indicator going to turn? What color will litmus paper turn, and in which context? Be very, very careful Carboxylic acids are the only ones that are acids and that will make those color changes. Alcohols do not. Even though both of these have an OH group, only the carboxylic acid is able to donate the hydrogen ion. An alcohol will not be able to do that, so these will all remain the same color. If I did want to test for an alcohol, we would then use dichromate. We could also use permanganate as another option, and permanganate would have the same color change, and dichromate would have that orange to green color. And this is something that you guys have learned previously as one of the oxidation reactions when you were doing the reaction schemes and properties of alcohols. We will do oxidation in our next topic of redox, so you'll know more of what that means. So those are just all your tests. Best thing to kind of do is memorize them. I have links on the Google site to flashcards, or you can make your own. I thought it was quite useful to create a flow chart for the organic compounds. Be mindful that this is not something that you'll be given. If you want to use it, you can memorize it, but I don't think it's that critical. It's just useful to think about. It's also really good if you're trying to have a nice polished excellence answer, if you can think about how can I do things efficiently without wasting reagents. Because if I can predetermine what something is to begin with, I can save some reagents. So like, for example, we know that the carboxylic acid and the amines tend to be soluble. And so if my substance is soluble, then I wouldn't do a test with their permanganate. Again, like I said, it just makes things more efficient, but it's not the end of the world if you say you do a permanganate test and there's no color change. But I would first suggest, whenever you're thinking about this, start with water, because water can basically tell you long or short carbon. Long carbons will be insoluble, short carbons will be soluble, depending on the function group you have there, because we know that if I have an alkene or an alkane, there's nothing that is going to result in a polar molecule, so those will be consistently insoluble. Alcohols can be soluble in water, it just depends on the length. So do kind of keep that in mind. This is not a perfect kind of flowchart because you are factoring both functional group and carbon length. So yeah, and you can use this, like I said, as a means to kind of test to see what's going on and doing some confirmations. Certain things will react and other things won't. So for example, potassium permanganate will react both with alcohol and an alkene, but the alcohol will be the only one that works with the dichromate, and alkene won't oxidize with the dichromate because that is not a strong enough oxidant. The bromine water will only react with the alkene to break that double bond. It's not going to do anything with the alcohol. So like I said, ways that can easily kind of confirm it. And like I said, with the acid, the carboxylic acid, you would just do a litmus test and you can confirm it using a carbonate, which will basically create bubbles. So yeah, just a way to think about it. What I want to do now is just kind of walk through an exam question. I won't fully answer it, but I'll show you guys how to process it, to pull out key information to basically set yourself up to answer it. So let's just swap now over to my OneNote, and I can write on this screen here. Do it in red pen. I do it in a thicker red pen. We'll do it then. All right, so we read it has labels have fallen off 3 colorless bottles. And that's the problem with organic chemistry. So many of our organic liquids are colorless, so there's no real way to kind of tell the difference. They have given me a list, and they'll always give you a list. There's ethanol, hexene, and propionic acid. What I always like to do is I like to annotate these questions both with 2 things. 1, how many carbons are there? And 2, what's the functional group? It'll help me organize then what I'm going to do testing-wise. So ethanol here is 2 carbons, and that is an alcohol. Hexene here is 6 carbons, and that is an alkene. And then propionic acid is 3 carbons, and that's a carboxylic acid. So that'll help me kind of get organized. The next, it then talks about, explain how you would identify the liquids using a solution of sodium hydrogen carbonate. and your knowledge of physical and chemical properties. So they've only given me one reagent to test. Other times they give you this question, they give you a free-for-all, and you can choose anything you want. But in this case, they haven't. They have told me what I have. It's really important then that you have the different identification tests memorized, because if they give you something like this and you don't know what it does, and you're like, oh, I know how to test for carboxylic acid, I need a litmus paper. Litmus paper isn't one of your options. So it is important that you know all those guys. So sodium hydrogen carbonate is your base. You guys used this last year when you mixed it with acids, and the big thing is that it tests for acids. And basically, the positive result is bubbles, which is your CO2 gas that's coming off. Basically, the hydrogen carbonate acts as a carbonate. Cool. So, next thing, make sure you pay attention to these bullet points, because you need to answer each one of those to get the full marks. If you have forgotten any of them, you won't be able to get your maximum marks. So as you're writing your answer, make sure you are ticking these off as you're going to make sure you haven't missed anything, because I've seen a lot of people miss out because of they forgot their observations. So observations are really kind of what you'd expect they are. They're basically saying, like, do you see things mixing together? Are they soluble? Are there bubbles? Is there color change? That sort of thing. And do give a list of each unknown that you're testing and what you'd expect. They want you to link your observations to the chemical or physical properties. So basically you're talking about, not soluble in water or chemical reaction that's occurring. So like the proponic acid is being neutralized by the carbonate. And then they want you to write chemical equations. This equation bit really throws a lot of students off because they forget to do it, or they don't know what they are supposed to do with those equations, and they don't bother asking it. And you really can't get yourself an excellence if you don't know how to do those equations. So basically for this question, what I would, and I should also add something that often people forget is this bit here. I'm going to do it in a different color so we don't miss it. Aqueous. That's a really important thing, because even though they've only given you one reagent to test your unknowns, the fact that this is aqueous also means that you have water. And that can help you with that identification process. So assume you have water, because when it comes to these identification reagents, it's going to be dissolved in water. I'm just going to kind of quick fire through my answer. I'm not going to do a proper written one because I'm going to show you the marking schedule. But basically what you should be thinking about is ethanol is going to it's going to be miscible. I can't spell. We're just going to say it. Soluble in water. But no reaction. With the hexene, it'll be insoluble, and that's how I'm going to find it. And then the proponic acid is going to be soluble, and bubbles will form. Now, obviously, all I've done right here is done that first step of state observations. I'm not going to link it because you guys can link it, and hopefully you know some of your chemistry about what's happening. I will give the equation, though, because a lot of people struggle with these chemical equations. So, proponic acid, CH3CH2COOH, is reacting with the sodium hydrogen carbonate. With that, it will get neutralized. So with that neutralization reaction, that's going to be losing a hydrogen ion, and we are going to be forming water from that. Now I gotta figure out, it's probably going to be H2CO3, but I'll double check the marking schedule. Anyway, that's what we're thinking about with that. The next question here is the next step. So they want you to say, explain how you could use an alternate reagent to do a chemical test that would distinguish between the hexene and the propionic acid. So in this case, they have given you free range and you can pick anything you want. Again, make sure you're using these bullet points. Identify the reagent, state the observations, and again, identify any type of reaction occurring. So basically, identifying if it's like a substitution, oxidation, neutralization, that sort of thing, addition, that sort of stuff is what it's asking for. So that's basically what you're looking at for that question. Let me now open up the marking schedule so you guys can get a better look at some of these ideas. So you can see with B, it's talking about adding sodium carbonate to all three solutions and how you would distinguish it. Just want to see if my equation was right. No, my equation wasn't right because I'm being silly. Duh. What am I doing? Wow, this is level 1 question. All right, let me get some more space. H2O plus CO2. And that's what the bubbles are. I should have realized that earlier. Anyway, so yeah, that's what we're looking at. Hopefully that's pretty straightforward. The excellence obviously is the correct procedure justifying each liquid with the chemical equation. You can't get away with that. You need to have it for the excellence, so you need to know some equations. Link the observations to a chemical or physical property for one molecule. There were 3 there, so you basically got 3 chances to show that for the merit. And then for the achieve one correct observation or one correct organic product name or formula. Again, really super generous. So I think you're going to struggle with the product because the only one that has a product is that sodium propanoate, which is the salt, which I don't know if you would get, but they might have been generous and said water or carbon dioxide as a product. So that's our first part. Second part here is really, really long, but that's only because it's accounting for all the various things you could have chosen since it was an open-ended question. Again, be mindful for the excellence. You need to explain your reactant, your observations, and the type of reaction to distinguish the molecules. That basically means you have to answer both parts. For this one here, you linked the reagent to the correct observation or type of reaction. It's then saying that you got one of them right instead of talking about both of them. So do be mindful with these sort of questions. Don't just think about identifying and writing up and explaining one. Explain the negative result as well. Because that is part of distinguishing. For the achieve 2 points, either you named a correct reagent or you gave a correct observation. So pretty generous all on those fronts there. So that is that question. All right. So, Kapai, really good work today. So, just to summarize what we learned in today's lesson, you should be able to process how to identify unknown organic compounds. You might be asking, okay, what do I do next? So, with this next step, this is basically a lot of independent kind of work for this material because you just need to practice it. First off, just work on some of the recommended tasks on my Google site. Pick any of them because they are differentiated with the cell-wise process. You are not expected to do all of them. Just pick whatever works for you, but do make sure that you are showing you are doing work by putting it into that Google Doc that says evidence of week 5 lockdown work. Your teachers will be checking that and giving feedback to HOHs if based on that information. So you can either type into that document itself, or you can handwrite your answers and take a picture and put it into that Google Doc. I know books are stuck at school, so there are actually. Let me show you guys that later. The other thing is that you will have a CPR quiz for as well this week. So do complete that. Both of them are on Google Docs in that assignment. So last thing then, if you are in my chemistry class, Ms. Garlick's chemistry class, please make sure you keep doing your weekly check-ins. You're doing the weekly check-in for week 5. Same questions as always, but the random question for this week is, who is your favorite band or musician? That'll just be something for us to chat about when I see you guys during our Google Meet. So yeah, that's basically everything. I'm going to quickly go to my Google site so I can just show you what I mean. For how it's going to look. Oh, I didn't hit update. Let me update my website first, and then you guys will be able to see it. It didn't hit publish. Cool. Let me refresh the page. I'm just going to click on the link. Hopefully it's showing what I wanted to show. No, I've just published you. Why aren't you showing? There it is. Okay. Cool. So obviously the video isn't in here yet because I'm recording it right now, and I will put in the notes that I wrote on my OneNote. Here's just your instructions. Like I said, no specific homework, but do the follow-up task and the CPR quiz. I put the answers to the CPR quiz there once you guys are ready to check it. That's the PowerPoint that I showed you guys. These are some useful resources. No Brain Too Small has really great kind of summary stuff and flashcards. I also created flashcards as well. And here's the recommended follow-up. So there's Education Perfect. If you do want an Education Perfect subscription, just let me know. I can add you, and you can pay for it online because it'll prompt you online. Or you can just make some flashcards if you're really kind of wiping out. Here's a Stand, Surf, Soar. So Stand and Surf both have SciPad pages. There's no ESA pages because the ESA guide doesn't have a section on identification tests. They're kind of interwoven into each kind of functional group section, so that's why I haven't included it. I know your SciPads are at school, so these hyperlinks will open up to a PDF of the image of those pages, so you can still access it. And I've also included the PDF for the answers for each one of those sheets, so that way you can check your work. But that's basically it. So whatever you work on, please put the evidence of that work in that Google Doc for week number 5, and also get that CPR quiz done. But that's all you got to do for this week, and hopefully we'll be back at school soon.